good evening. This video is going to talk about graphing parabolas, and it's going to have two parts. The first part is going to be me walking you through how you can actually graph a parabola by hand. The second part is going to be me showing you how to actually use a graphing tool to do this electronically. The reason that I'm splitting this into two parts, and the reason why I'm taking the time to do that, is in most cases you are not expected to actually graph these by hand. Essentially, in the case of most states, the standards want you to actually understand this, so your teacher is going to spend time trying to make sure you understand the process of graphing this by hand. But in most cases, it's actually okay to use technology. There are some exceptions, but what I've ran into personally as a teacher, not all of my students have graphing calculators, and I don't even have graphing calculators for every student. So even though you can use a graphing tool on the state test that you might take, I don't necessarily have it available for everybody in the class. And if you have a graphing tool, it's easy. You just plug in your equation, it spits out the graph, and you're done. To do this by hand, though, takes a little bit more finesse. And I think the reason for that is that everybody is so used to linear equations. Like most of middle school, your teachers focus hard on straight lines. How do you graph a straight line? What are the characteristics of a straight line? And students get accustomed to graphing those, and in many cases the teachers tell them, if you want to pick some points to try to graph this line, you can start at 0, and then maybe you go to 1, then maybe you go to 2 for values of x. And the problem is that just doesn't work with parabolas every time. So I want to get going with this and kind of reflect back on some of the points I just made. So a parabola, anytime you see that word, we're talking about a U-shaped graph. Now there are some features on this parabola, some vocabulary that you have to know. So in addition to knowing that that's a parabola, whatever this point is down here, that is in this case the minimum, the lowest point on this parabola, that's called your vertex. And that's really important because it actually cuts the parabola in half. So at this point, your parabola on the left side is going to be symmetric with whatever part is on the right side. And what I mean by symmetric is, if you were to draw a line, I'm going to make it dotted just so you can see it. If we were to put a line straight through this parabola, I could take the left side, fold it onto the right side, and it should be a perfect match. This line that goes right through the middle is this thing called the Axis of Symmetry. So again, another vocab word you have to mean, but you have to understand. But it's pretty straightforward. Axis meaning a dividing line in this case. Symmetry meaning it's symmetric. If I were to attempt to graph this, I'm going to actually need a graph. I'm going to need an XY graph, which I've drawn over here. Sometimes you'll see that referred to as an XY plane. If you ever see Cartesian plot, same thing. And basically, I'm just going to look for numbers that I can substitute into this equation, solve it, and plot over there. Now, in my experience, I've got some students that when they see this, they're like, oh, that's super easy. I completely understand it. And I've got others that honestly didn't quite grasp how this process worked even with linear equations in middle school, and they have a hard time now because these are a little more complicated than linear equations. So as a quick review, anytime you have an equation, in this case it's a parabola, it's a quadratic equation, if you see y's and x's like we have here, y equals x squared plus 14x plus 4. If you see x's and y's, that means you can graph it on an xy plot. Now, you can't just put it anywhere you want to. It has a specific place where it needs to be. But it'll go on there somewhere. So you can, rest assured that as long as I've got X's and Y's, I can fit it on here. If we were just graphing a straight line, you could pick any value for X that you wanted to, and it'll work out in most cases. Because the straight line, wherever it starts, it's going to cross your entire graph, and most of the problems are set up so that whatever equation you get will fit on the graph. The problem with parabolas is this vertex is the middle of your parabola. So unless it is in the middle of this graph, you can't just pick any value for X that you want to. And what I'm saying for that, what I mean by that is the easiest value to pick for X would be, hey, let's see what happens if X is 0, which is the center of this graph. But if this parabola isn't in the center of this graph, whenever you substitute 0 in, what's going to happen is you're going to get a value out because it'll be somewhere on that graph. But it's not going to be the part of the parabola that actually looks like a U. It's going to wind up being somewhere up on this graph. That's what that arrow means. It means that graph keeps going. So for example, if I had a parabola like this, if you pick 0 for X, it's going to have a Y value. But if you just start plotting here, you've got a long way to go before you even figure out that it's a U shape. So the strategy that you have to use whenever you're graphing parabolas by hand, one, you can rewrite this and put it in vertex form, which we'll talk about in another video, and your teacher will probably show you how to do. Or you can find this vertex to begin with and let that be the first point that you do. So in other words, let's say I wanted to graph this parabola. I don't want to start over here on the right side. I want to start right in the middle. Okay, so how do I do that? This axis of symmetry that you see here, there's a formula for it that actually gives you the X value. So the axis of symmetry equals negative b over 2a. Now if you're wondering what this means by the b and the a, look up the standard form of a parabola and you will see that it is ax squared plus bx plus c. So the a refers to whatever the coefficient is in front of x squared. In this case we just have x squared, so that means you have a 1 in front of it. And b is whatever coefficient is in front of the x, which in this case is 14. So I'm going to use this formula now. And again, I didn't just make this up. This is another thing that in algebra you have to memorize. You've got to know that the axis of symmetry is that formula. That's how you find it. So to use it now, what I'm going to do is I'm going to say, all right, b equals 14. This formula says that if I take whatever b is, make it negative, and divide it by, that's what a fraction bar actually means, divide by 2a, then it's going to give me the axis of symmetry, specifically the x value of the axis of symmetry. So you literally just plug in. Now I've heard people say like, this is where you plug and chug. Yeah, it's called the substitution method. You're using the substitution property. So if your teacher ever asks you how to do it, you substitute. Negative 14, I replaced 14 with b, divided by 2 times a, which is 1. Which gives you negative 14 over 2, which is negative 7. So what that tells you is this parabola here, this x squared plus 14x plus 4, when we go over here and we try to graph this, the middle of it, this vertex, is sitting over here where x is negative 7. So again, had we picked like 0 for x, it would not have worked out. So let's do this. A lot of my students get stumped right here. And they'll work through, they'll find this, and they're like, well, now what do I do? Well, literally, you can just make a table of values. And this is true, again, for any equation that has x's and y's. So what I'm going to do here is I'm going to say, all right, if I have x's and I have y's. Y, though, is what I'm going to be trying to find in this case. X will be whatever I want it to be. This is y equals. So whatever I pick for x to be, I can solve it and I'll get y out. So I know that I'm going to need to use negative 7 because that's the middle of my parabola. And I'm going to need to substitute it in. Well, what am I substituting in? Again, you're substituting it into that equation. Y equals x squared plus 14x plus 4. So literally, your y here is going to be equal to negative 7 squared. I'm just putting the negative 7 anywhere there's an x. Substitution property again. This is going to be where a calculator is very helpful. Some of this you'll probably know immediately, some of it you may not. So negative 7 squared. Remember, a negative times a negative is a positive. That squared means I take whatever I am squaring and multiply by itself. In this case, you're going to multiply two numbers. So negative 7 times itself, meaning you literally have negative 7 times negative 7. That's what negative 7 squared means. But because it's a negative times a negative, you get a positive. So negative 7 times negative 7 is positive 49 plus 14 times negative 7. You could figure that out potentially in your head. You could write out, or you can use a calculator, which I recommend just to speed it up. That's a positive times a negative, so your answer is actually negative 49 plus negative 98, and then plus 4 just kind of comes down because there's no variable with the 4. So 4 is still part of it. You're still adding 4, but there's no x with it, so you just put that down here. So now you've got 49 and negative 98 and a 4. When you add those together, you're going to get negative 45. So I'm going to move over here now. So what we just established was, I want to find x, y values. Negative 7 is the middle of this graph, and I want to put it somewhere on here. So we'll see, negative 7, 1, 2, 3, 4, 5, 6, 7. The issue, though, is now, what's my y value? Negative 45. That's a pretty big number. So you can't just go down the y and be like counting by ones. I mean, you can, but you're going to need a really big graph. So I'm going to go by tens. Okay, so if I go back negative 7, that's here, and I go down negative 45, that's going to be about right there. Well, now what? I just found the middle of my parabola. So I need to find another point. So essentially what you'll wind up doing here is the same thing I already did over here, but with other values for x. So now I'm going to continue on with my table for x and y, but now I'm going to have negative 8. I picked negative 8 because it's immediately next to it, like it's the next consecutive integer. And if this is symmetric, then I've only got to find where it curves on one side, and then I can automatically find the other side because their y values are going to be the same. And I'll show you what I mean by that. So with negative 8, you have negative 8 squared plus 14 again times negative 8 plus 4, which is 64. 14 times negative 8 will be negative 112. And then you still got that plus 4. And you actually get negative 44. Okay, so negative 8, negative 44. Negative 8 is going to be here. Negative 44 is going to be like right here. And so that means this parabola is going to be doing something kind of like that. And you actually don't have to do much else. You need the other side of the parabola, but the way you can do that is to say, if this is negative 8 and I only went 1 unit, then if I want to go 1 unit to the right, I can go from negative 7, which is what I started with here, to negative 6. Now you can work this out. You'll get negative 6 squared plus 14 times negative 6 plus 4. And if you work that out, you wind up with 36 minus 84 plus 4, which is negative 44 all over again. You should notice that these equal. That's because parabolas are symmetric. So any point you find over here is going to have a mirror image on the other side. So at negative 6, I'm also at 44. And that's why I made the comment before that you really don't have to do any more work after you find this. Unless, finding a third point sometimes is nice. So like you could have done negative 9 and figured out where it's kind of going. But once you find one side, you've already found the others. You just have to go in the x direction the same amount and find the y value that matches up. So in other words, negative 9 would be on the other side of negative 8. Whatever y value you get for it will be the same y value you get for negative 5, which is on the other side of negative 6. Should look something kind of like that. And this is how you can sketch a parabola. If you wanted to make it more precise, the best way to do it would probably be to work with these points until you figure out where it actually crosses the x-axis, and then you can make it look nice. Also with graphing paper, it'll probably come out. So that's it for part 1. Now I'm going to move on to part 2, where we actually use Desmos.com to graph this. Hello. Alright, so I hope you got something out of part 1. My guess is some people are going to look at that, and figure like, oh, that made perfect sense, because I already know how to plot straight lines by finding points. And this really isn't any different. It's just that you've got that quadratic equation, that parabola, which is a slightly more complicated equation because you've got that square in there. And you've also got the variable of x showing up more than once. Others are going to look at part 1 and honestly, kind of get lost. So here's my recommendation. First off, make sure you understand what it means to substitute into an equation. So make sure you understand what the substitution method is. Make sure you understand what it means to evaluate an equation, to evaluate a function. If you don't, look those up. Also, it's probably not going to help you to just watch the video all the way through and just expect to understand. Again, some people can, but not everybody will, depending on your background with this topic. So pause the video, rewind it, think about what I said, potentially try to work out some of this on your own. Like try that where I worked out like what happens when you plug in negative 6 and negative 7. Try that on your own and see what you come up with. So what I'm going to do now is I'm going to go to Desmos.com, and I'm going to demonstrate, basically how you can do this, but with a graphing tool. Now, if you've got a graphing calculator, it will do it as well. But Desmos is free. You can go to the website, which is Desmos.com, and it's pretty nice because they have apps as well. So you can download the app for the graphing calculator or the scientific calculator for Android and iOS, which is, again, it's nice because you could have that in your pocket even if you don't have a graphing calculator. Most people do have phones. If nothing else, you can access this on the internet as well just by going to Desmos.com. So I'm going to click Start Graphing. So just as a reminder, the equation was y, and look, I'm just literally typing it on here, y equals x. It was x squared. So there's two different ways you can do this. If you know the shortcuts on the keyboard, there's like a little, I think it's called a caret. It's the symbol that's on the keyboard with the 6, so you'll have to hit Shift 6. You can use that to create exponents, or you can come down here to where it's got the little keyboard, click Show Keyboard, and it allows you to do exponents. So I'm going to hit this a squared, and it automatically added the x squared. And it was x squared plus 14x plus 4, so now I'm just going to literally do plus 14x plus 4. And so notice, like at first it looks like this, and you're thinking, that doesn't even like a U. Gotta zoom out. And this is what this thing actually looks like. So if you remember, I made the comment like, wow, these y values are getting to be pretty big. So even though your vertex, we said, was at -7 for x, the y that came out was -45. So I said, you're going to have a big graph. And look what happens here. You can come back to -7. Notice this is -10. So -7 is going to be somewhere right around here. And real quick, I'm going to put this on projector mode. Makes it a little easier to see. So -7 is going to be somewhere in this vicinity. But look at the y value. It's way down here. But you can click that. And as long as you find it exactly, the system knows that's a vertex. You can actually click it and look, it's labeled it for you. So -7, -45, that's my vertex. And if you notice, I didn't even have to do that whole axis of symmetry formula. I didn't have to do that -b over 2a. I just plotted this. But again, my goal isn't so much to make sure that you can use a graphing calculator to get all your answers. My goal is to make sure you understand the idea, which is we're just trying to find the x and y values. Again, there is this thing called Vertex Form, which you can do, that does make it a little easier to graph. But if you don't have that, if your teacher gives you the opportunity to use a graphing tool, then basically what's happening is you're going to find the vertex, and if it ever says to also plot the zeros or plot the X-Intercepts, that means where it actually crosses the x-axis up here. But if you notice on Desmos, it gives you those too. So on this particular one, look, it's not a nice number. It's -13.708. So it's close to -14, but it's not -14. So if you were having to put this in maybe as some online homework or something, you need to pay close attention. If it ever says round, it'll say round to the nearest 10th, round to the nearest 100th, that's usually a pretty good hint that it's looking for a decimal answer. And in this case, if it said round to the nearest 10th, well, that's -13.7. If it said round to the nearest 100th, you come out to the 0, but since there's an 8 next to it, you round up, so that 0 becomes a 1. So to the nearest 100th, that'd be -13.71. Then over here, again, your x value isn't a pretty whole number, it's a decimal, so -0.29. It's pretty close to 0, so it's pretty close to the origin there, 0, 0, but it's not quite there. And this other point on here, that's the y-intercept, so to clarify, these are your x-intercepts, where it's hitting this x-axis. Your y-axis is your vertical one, going up and down. So 0, 4 is where it hits there. So a lot of times this will tell you, a lot of times your homeworks, like they'll ask for you to plot 5 points. That's just kind of the going thing, which means the vertex and then 2 points on either side. And what I was talking about before when I said this was symmetric is, if you notice here, the x values are different, but like the y values are 0 on both of them. And if you come down, so even like right about in here, your x value is negative 13 almost, and the y value is like right at negative 9.9. Well, right here, your x value is totally different, negative 1. It's nowhere near negative 13. But notice your y value is still negative 9.954. So if you're ever having to do these by hand, if you can get one side of it, then the y values, which is telling you how far up and down to go, your vertical portion of the xy graph, you can take the y values from one side, so like the left side here, and you'll already know what the y values are going to be on the right side. Most of the time, the examples you get will work out, just meaning even with any kind of practice materials that you use, textbooks, workbooks, they tend to give you nice graphs, nice equations, nice functions that turn into a nice graph. But if for some reason it didn't, this is where having a graphing tool would be a great help. So just to kind of close here, with Desmos, you can graph anything you want to. Anytime you get a new equation, you'll just go up here, click, add a new equation. You can click the one you already did and delete it. And basically you can just look at whatever's plotted, and that tells you where it's going to be, like if you had to do it for homework or something. But if a teacher ever said show work, show me how you did it, well, that's where you really need to be paying attention to part 1 of the video, because that's what you'd have to be showing. Yeah, so I mean that kind of wraps up the initial information about graphing. This is generally the most rigorous unit in algebra. Again, it used to be in Algebra 2 for most states, but with Common Core being rolled out, it got pushed down to Algebra 1. There's kind of some back and forth between Algebra 1 and Algebra 2. This stuff is kind of tricky because you probably haven't seen anything like this before, so just be patient. It's okay to not understand it the first go around. It's okay to not understand it the second or third or fourth go arounds. Just keep trying, keep asking questions. Feel free to leave comments regarding this video if there's anything that you'd like clarity on, and I'd be happy to help.